Hello friends. Now in last lecture we have studied a step down chopper. Now we will see a step up chopper. Okay. Now as a, again name indicates, step up chopper is a chopper where output voltage is greater than the input voltage. Since it is called as a step up chopper or it is called as a boost converter. Okay. Step down chopper is called as a buck converter. Step up chopper is called as a boost converter. Okay. Now you can see its construction. Then input voltage. Inductor is in previous step down chopper. Here there was a switch and here was a diode. Now thing is, here there is an inductor, here there is a switch, diode. One can show capacitor also across the load. Okay, no need to show it, or you may show it. So this is a load. So this is the circuit. Okay, how it works? So when switch is on, the supply passes through inductor and switch like this. See this diagram. When switch is on, it is conducting like this. Okay, so output the side there will not be any voltage, but current it is there. Why? I will tell you later. Okay, so it is conducting like this. Now when switch is made off, that time what will happen? The inductor will try to maintain the current in same direction, so it will develop voltage L di by dt across it. So output voltage will be this Vs plus voltage developed by inductor, that is L di by dt. So Vs plus L di by dt, this is the total voltage which is applied to the load. Okay, so this is here we can see, here we can see. Okay, Vs plus L di by dt. Okay, now current, obviously when switch was closed, so load side there will not be any current. When switch is off, then again there is a current. Okay, why it is I2 to I1? Because inductor will get discharged at some time. So this total current I2 is current of from source plus inductor, and then it will decrease to I1, which is by source only. Okay, and this is the supply current. When inductor is means when it switches on, so current through inductor will goes on increasing. It will charge conductor inductor. At this point switch is made off here. So from here inductor will discharge. Source is there, but inductor will discharge to this point. Okay, below this source is supply. Are you getting? This is input voltage, this is input current, this is output voltage, this is output. Okay, so actually source voltage will be somewhere here, but source plus inductor is a total voltage which we can see at our. Okay, so this is a step up job. Output voltage is given as a V0 equal to Vs upon 1 minus t, where d is a duty cycle, T1 upon t. Okay, this is the example again from a book PSP Mara. So you can see here a step up chopper has an input voltage of a 220 volt. Okay, and output voltage of a 600 volt. So output V0 average is given. Which one? This is output is given and this input is given. If the conducting time of a thyristor chopper is 100 microsecond, conducting time means T1 is 100 microsecond. Okay, compute the pulse width of the output voltage. So what should be the pulse width? In case output voltage pulse width is half for constant frequency operation, find the average value of a new output voltage. If width of the pulse is made half, then what will be the output voltage? Let's see. So first of all, they have given with the output voltage and input voltage. Output voltage is 660, input is a 220. Output is a 660, input is a 220. So 660 is equal to 220 into 1 upon 1 minus d. Here they have used sign, alpha. It is d. Okay, duty cycle. Okay. Now what is duty cycle? Duty cycle is given as a t on by t. Okay, duty cycle is given as a t on by t. Now this figure 7.6d means this figure only. Okay, this figure. Now we can see that from figure the conducting time of chopper is 100 microsecond. Conducting time of a chopper is a 100 microsecond, but on time is 2/3. Here they have considered on time is a 2/3 of the complete time. Okay, just a minute. When they say figure 7.60, let me see. Okay, so they have considered on time duty is a 2 by 3. Okay, so T1 is equal to 2 by 3 into T. Right? Are you getting what I'm saying? Duty is they are considered from this diagram. They are considered this is as a two-third time. Okay, on time is a two-third time. Okay, on time is a two-third time. So D equal to two-third T on by T. So on time is a two-third of a T. So T on equal to two-third of a T, that is equal to 100 microsecond, which is given. Okay, so from this we can find out T equal to 100 into 3 by 2, 100 into 3 by 2, which is a 150 microsecond. Okay, now pulse width of the output voltage will be equal to T off period. Okay, so during T off period, rather T off period is nothing but main timing T minus T on period. So timing T is 150 microsecond minus on time T on is a 100 microsecond. So off period is a 50 microsecond. Okay, here this off period is a 50 microsecond, which is nothing but a pulse width, because at off period only we are getting output. No, are you getting what I'm saying? At off the switch off period we are getting output. Hence off period is nothing but pulse width of our output voltage is a 50 microsecond. Now, if we have made half of this pulse width, 50 by 2, that's 25. What will be the difference? Now, for constant frequency, frequency is to be constant. It means time, this complete time t should not be varied because frequency should be constant. So, t equal to 150 microsecond we have to use, right? Now, on period will be 150 minus this off period. Okay, because off period is half now. So on period is 150 minus 25, that is a 125 microsecond increased. What is alpha, or rather d is t on by t. So t on 125 by t, that is a 150, that is a 5 by 6. So new d is 5 by 6. So put it in the formula. Average output voltage, which are now 660 is not average, we will get new average. So that average equal to 220 into 1 upon 1 minus d. D is a 5 by 6. So we will get new output as a 1320. Are you getting? Means if we made the rather if we increase the on period or we decrease the duty, then ultimately output will be increased. Okay, are you getting what I'm saying? If we increase the T on period, ultimately D is increased, so we will get higher average output voltage. Okay, this is for a step up chopper. In next lecture, we'll study about a step down chopper. Thank you.